Good morning, students. Here we are going to discuss the second part of current electricity. In this second part, we will be discussing here the different topics. The topics I have written here: flow of electrons between the two charged bodies, then direction of flow of electric current, third point electric potential, then potential difference, and the last topic is resistance. Okay, let's start the first topic: flow of electrons between the two charged bodies. In figure 1, I have kept here one positive charged body and one uncharged body, right? B has no charge, A has positive charge. Now if you will connect with a metallic wire, then you will found that electron starts to flow from negative, from uncharged body to positive charged body. Electrons flow from uncharged body to positive charged body. Why? I will explain later on. In the second figure, if you will join with a metallic wire, then you will found that electrons flow from object C to object D. Electrons flow from C to D because C has excess of electrons and D has no charge. Okay. The third figure, if we will join with the metallic wire, we will see the electrons flow from E to F. Okay, now let me discuss elaborately why it has happened. In figure 1, A has positive charge. Positive charge means it has lack of electrons. It has deficit of electrons. Whereas B is uncharged, means it has number of electrons and protons both are same. Since A has deficit of electrons or lack of electrons, so electron starts to flow from B to A. And in figure C, C has excess of electrons. So because of excess of electrons, electron will flow from C to D. And obviously figure 3 is very easy to understand. E is negatively charged body and F is positively charged body. So E has excess of electrons and F has deficit of electrons. So electron starts to flow from E to F. So what we have understood here, that electron starts to flow from one charged body to another charged body as long as the concentration of electrons does not come in the same manner or same amount. So concentration of electrons maintain the flow of electrons, means as long as the concentration of electrons is not same, the electrons continues to flow. Now from here we will get the idea, the second part, direction of flow of electric current. So direction of flow of electric current, I am discussing here the second part, direction of flow of electric current. Let me draw two objects. One is positively charged and another is negatively charged. Now let's take, this is A, this is B. If we will join with a metallic wire, we will found that electron starts to flow from B to A because B has excess of electrons and A has lack of electrons or deficit of electrons. So electron starts to flow from B to A. So this is the direction of flow of electrons. This is the flow of electrons. But we know that from our common sense that, or in lower classes we have learned that current starts to flow positive to negative potential. So we can say, yes, we use one term, potential. So that potential we will discuss in the next topic. So we can say here from this diagram that B is negatively charged body, A is positive charged body. So when we join with the metallic wire, electron starts to flow from B to A, and this is the direction of flow of current. So this direction of flow of current we can say in another way that electronic current. So that means we can say electronic current starts to flow from B to A. Now another direction we can say just opposite of electronic current, that is called conventional current. Conventional current. Simply we can say this is electric current. This conventional current, simply we can say electric current. So we can say as a conclusion that electrons flow from negatively charged body to positively charged body. It constitutes an electronic current. In the opposite direction of the electronic current, another current flows, that is called conventional current, or simply we can say electric current, right? So what is electronic current? Let me discuss. The flow of electrons takes place from negative potential to positive potential, that means from low potential to higher potential, whereas conventional current flows from positive potential to negative potential, means positive potential means higher potential to lower potential. Now we will discuss the second topic, electric potential. What is electric potential? Let me discuss as a definition. Electric potential we can define as the amount of work done to bring a positive test charge, positive unit test charge from infinity to a point in an electric field. So again once more let me discuss. The electric potential can be defined as the amount of work done to bring or to transfer a unit positive test charge from infinity to a point in an electric field. Mathematically we can say if W be the amount of work done and Q be the amount of charge we are bringing from infinity to a point in an electric field, then electric potential we can write as W by cube, right? W by cube. So unit of electric potential, W is measured in joule and charge is measured in coulomb. So joule coulomb, or we can say joule coulomb inverse, simply we can say, or volt. Simply we can write capital V. Capital V stands for here volt. Electric potential is measured in SI system either joule per coulomb, joule coulomb inverse, or volt V. Now the second last part. Potential difference. Potential difference can be defined as the work done to bring a unit positive test charge from one charged body to another charged body. Again once more, electric potential difference can be defined as the amount of work done to bring one charged body to another charged body. If W be the amount of work done and we brought cube amount of charge, then potential difference we can write PD V2 minus V1 is equal to W by cube. Right? This is the mathematical formula of potential difference. Now potential difference also can be measured in terms of joule coulomb inverse. So unit of potential difference also in SI system joule per coulomb or joule coulomb inverse or volt. Simply you can write capital V. Again once more let me discuss. Both electric potential as well as potential difference are measured in same unit, and since they have no particular direction, they are so called scalar quantity. So last topic is here resistance. We have seen that whenever anything flows from one place to another, there is some obstruction. So when current flows through a conductor, let me draw the conductor a little bigger in size. Okay, so here the molecules are there, better to say atoms of element, atoms are there. So all around the atom, suppose think that one of the point is one atom, all around the atom there is electrons. So when electrons starts to flow, suppose this end A is higher potential, means positive, and B is negative potential, so lower potential. So we can say electron starts to flow from B end to A end. When electron is flowing, there is some obstruction. There is some obstruction offered by the electron as well as the nucleus. So again once more, let me tell you, when current flows through a conductor, means, better to say, electrons flow from negative potential to positive potential. So we have seen that electrons flow from one end to another end. So when electrons flow from one end to another end, there is some obstruction. These obstructions offered by the conductor itself, in simple way you can say, is called resistance. So resistance can be defined as the obstruction offered by the flow of electric current when it is flowing through a conductor. It is also measured in ohm. So unit of resistance is measured in ohm. OHM, symbol you can say, this is the symbol, this symbol is named as omega, right? Thank you.